Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In today's session, we will discuss MPL Physics paper Weekend Test 15. So let's start with question number 1. The figure below shows currents in a part of electric circuit. The current I is. So we can apply KCL over here. So this current will be 2 plus 2, 4 ampere. Out of 4 ampere, 1 is going here. So 3 ampere will be here. Out of 3 ampere, 1.3 ampere is flowing in this branch. That means remaining will be 1.7 ampere. So correct answer is option 1. Next is question number 2. In the circuit shown in the figure, the current I is. So we can assume the potential of this point as V. So if you can assume that the current I1 is flowing in this branch and I2 is flowing in this branch, then you can write I is equals to I1 plus I2. Now what is I? So it is 24 minus V divided by 3 is equals to I1, that is V minus 10 divided by 2 plus V minus 9 divided by 1, right? So this is 24 minus V divided by 3 is equals to V minus 10 plus 2V minus 18 divided by 2. So 48 minus 2V is equals to 3V minus 30 plus 6V minus 18 into 3, right? So this is 54. Okay, so after solving this one, you can write 54 over here. 54 plus 30 plus 48 is equals to 9 and 11B, right? So this will be 132 is equals to 11V. So V will be over here 12 volt. So I current will be 24 minus 12 divided by 3, that is 12 by 3, and that is equals to 4 ampere. So correct answer is option 3. Next is question number 3. Find out the value of current through 2 ampere resistance for the given circuit. So 2 ampere is an open circuit. So correct answer will be 0 ampere. There will be no current through 2 ohm resistor. So correct answer is option 1. Question number 4. Kirchhoff's second law is based on the law of conservation of energy. Kirchhoff's second law is based on the law of conservation of energy. So correct answer is option 2. Question number 5. In an experiment of Wheatstone bridge, the positions of cells and galvanometer are interchanged, then the balance point will. So if this is the balancing condition. So P upon Q is equals to R upon S. If you interchange the position of galvanometer and cell, then you'll get P upon R is equals to Q upon S. So either ways you'll get the same result. So balance points will not change. It will remain unchanged, right? So correct answer is option 2. Next is question number 6. In the in the network shown, if the reading of the galvanometer is 0, reading of the ammeter is. Galvanometer is showing no deflection. That means you can remove this branch, right? And it is balanced. So 2 upon 4 can be written as R upon 6. Over here, R will be 6 upon 2, that is 3 ohm. Now 2 and 3 ohm are in series. So this will be 5 ohm. And this 4 and 6 ohm are in series, that is 10 ohm. Now 5 and 10 are in parallel. So equivalent of 5 and 10 will be R1 R2 divided by R1 plus R2, that is 10 by 3 ohm. Now this 10 by 3 ohm is in series with 10 ohm. So R equivalent will be 10 by 3 plus 10, that is 40 upon 3 ohm, and current is V upon R, that is 80 upon 40 by 3, that is equals to 6 ohm. So 6 ampere. So correct answer is option 3. Question number 7. If the balanced point is obtained at 25 centimeter in a meter bridge, the resistances in left and right gaps are in the ratio. So R1 upon R2 is L upon 100 minus L. L is 25 divided by 100 minus 25, that is 25 divided by 75. So R1 upon R2 is in the ratio of 1:3. Correct answer is option 4. Next is question number 8. When two resistances X and Y are put in the left and right gaps of the meter bridge, the null point is at 60 centimeter. That means X upon Y is 60 upon 40, that is 3 by 2. If X is shunted by resistance equal to half of itself, so when you shunt X with a resistance half of itself, nu x dash will be x into x by 2 divided by x plus x by 2, that is 3x by 2. So nu resistance x dash will be x by 3. So balanced point will, let's say, shift to L, right? So over here x dash upon y will be L upon 100 minus L, right? So x dash is x upon 3 divided by y is equals to L upon 100 minus L. But x upon y is 3 by 2, right? So it is 1 by 3 into 3 by 2 is equals to L upon 100 minus L. 3 cancel. So we have 100 minus L is equals to 2L, or 3L is equals to 100. So L is 100 upon 3, that is 33.3 centimeter, right? So new balance point is at 33.3 centimeter. So it will shift by 60 minus 33.3 centimeter, and that is equals to 26.7 centimeter, which is option 1. Question number 9. Resistances in the two gaps of the meter bridge are 10 ohm and 30 ohm respectively. The resistances are interchanged. The balance point shifts by. So again, let's say initial balance point is at L1 and final balance point is at L2, right? Okay, after interchanging. So for the first case, you can write 10 upon 30 is equals to L1 upon 100 minus L1. So this will be 100 minus L1 is equals to 3L1. So 4L1 is equals to 100. So L1 is 25 centimeter. Now, for second case, when we interchange the resistances, it will become 30 upon 10, which is L2 upon 100 minus L2, or 300 minus 3L2 is equals to L2. So, 4L2 is equals to 300 and L2 is at 75 centimeter. So, balance point will shift by L2 minus L1, which is 75 minus 25, and that is equals to 50 centimeter. So, correct answer is option 4. Next is question number 10. A potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves a condition of no current flow through the galvanometer. So that is why it is an accurate device. So correct answer is option 2. Next is 11. Sensitivity of potentiometer can be increased by. So sensitivity of the potentiometer can be increased by increasing the length of the potentiometer wire. Sensitivity is inversely proportional to potential gradient and it is directly proportional to length of the wire, right? So a correct answer will be option 2. Question number 12. Two poles separated by 10 centimeter experiences a force of phi Mn. Find the force between them when the distance is doubled and the pole strength are doubled, right? So force over here is directly proportional to m square upon d square. So if you are increasing the pole strength by 2 and the distance by 2, so m square upon d square ratio will be unchanged, right? Because it is 2m whole square. Now it is 2d whole square. So it will be again 4m square upon 4d square. 4 cancel. So force will be, again directly proportional to m square upon d square only, right? So force will not change and it will be option 1 only. Question number 13. A long magnet is cut in two parts in such a way that the ratio of their lengths is 2:1. The ratio of pole strengths of both the sections is, okay. So over here we have a long magnet and it is cut into two parts such that L1 upon L2 is 2 upon 1 and we need to find what is the ratio of their pole strength, right? So again, but your pole strength is independent of the length, right? So over here, the pole strength will not change and correct answer will be option 1 only, 1:1. Question number 14. Calculate the moment of couple required to keep a bar magnet of magnetic moment 2 into 10 power 2 in a uniform field of induction 0.36 Tesla and angle is 30 degree with the direction of uniform field. Okay, so over here torque will be mv sine theta. So this is 2 into 10 power 2 into b is 0.36 into sine 30 degrees 1 by 2. So correct answer will be 36 Newton into meter, which is option 1. Question number 15. We have 2 points A and B are located at distances 20 centimeter and 30 centimeter from the center of a short bar magnet on its axial line. The ratio of magnetic induction at A and B is. So magnetic induction is inversely proportional to R cube. So you can write B1 upon B2 is equal to R2 upon R1 cube, right? So it will be R2 is 30 divided by R1 is 20 centimeter whole cube. So it will be 27 divided by 8. So ratio is option 4, 27 is to 8. Correct answer is option 4. Next is question number 16. The period of a thin magnet in a magnetic field is 2 seconds. It is cut into 4 equal parts by cutting it along the length and breadth. The period of each of them in the same field is. So time period is directly proportional to under root I upon m, where I is the moment of inertia, right? Now over here what you are doing is you are cutting it to 4 equal parts, right? So moment of inertia will change. Let's say total length and width is A and B, right? So its initial moment of inertia of mass m is what? It is m by 12 into a square by a square plus b square. Okay, it is m square by 12 into a square plus b square, right? So this is the initial moment of inertia. After cutting it into 4 equal parts, new moment of inertia I dash will be m by 4 into whole by 12 into a by 2 whole square plus b by 2 whole square. Fine. So over here, new moment of inertia I dash will be m by 4 into 12 into a square plus b square by 4. Right, so it is nothing but I by 16. It is 1 by 16 times the previous one, right? So over here, if we find a new time period as t dash, so t dash will be directly proportional to under root of I upon 16 into m by 4 because I'm cutting it into 4 equal parts. Right, so this is nothing but directly proportional to under root of I upon 4m. You can take 4 outside, so it will be t dash is directly proportional to 1 by 2 times under root of I upon m. Right, so over here you can see that new time period is the 1 by 2 times the previous time period, which is 1 by 2 into 2, and that is equals to 1 second. So correct answer is option 1. Next is question number 17. A neutral point in the magnetic field is a point where the Earth's magnetic field is exactly neutralized by the Earth field due to a magnet. Right? So correct answer will be option 4. Question number 18. The magnetic moment of a short magnet is 8 ampere into meter square. What is the magnetic induction at a point 20 centimeter away on its equatorial line from its midpoint, right? So over here, magnetic induction is given as mu naught upon 4 pi into m upon r cube, right? So this is mu naught upon 4 pi is 10 power minus 7, m is 8 and r cube is 0.2 whole cube, right? So this will be 10 power minus 4 Weber per meter square. So correct answer is option 4. Question number 19. The incorrect statement regarding the lines of force of the magnetic field B is. So inside a magnet, its magnetic lines of force move from north pole to of a magnet towards its south pole. No, inside a magnet, field lines move from south to north, right? So incorrect statement is option 3. Question number 20. Isogonic lines of a magnetic map will have the same angle of declination. So correct answer is option 4. Question number 21. The vertical component of Earth's magnetic field is 0 at, or the Earth's magnetic field always have a vertical component except at the magnetic equator, right? So at magnetic equator, the vertical component of Earth's magnetic field is 0. Next is question number 22. The frequency of B is 3% greater than that of A. So let's say frequency of A is F and frequency of B is 1.03 F because it is 3% greater, and the frequency of C is 2% less than that of A. That means it is 0.98 F. If B and C produces 8 beats per second, the frequency of A is. So the beat frequency will be 1.03 F minus 0.98 F is equals to what? 8. So over here 0.05 F is equals to 8. So F will be 160 Hertz. So frequency of A is 160 Hertz, which is option 4. Next is question number 23. The velocity of sound in air is 306 meter per second. The number of beats produced by two sound waves having wavelengths of 50 centimeter and 51 centimeter in 1 second is. Right. So over here, beat frequency will be F1 minus F2, that is V upon lambda 1, which is 0.5 minus V upon lambda 2, that is 306 divided by 0.51, right? So over here, if you calculate this value, the value of beat frequency will be 12 Hertz, which is option 3. Next is question number 24. An engine running at speed V by 10 times sound a whistle of frequency 600 Hertz. Okay, so we have engine running at a speed of V by 10 and sounds a whistle of 600 Hertz, right? And a passenger in a train coming from the opposite side at speed V by 15 experiences this whistle to be of frequency F. If V is the speed of sound in air and there is no wind, F is nearest to. So, apparent frequency is F, right, over here. And apparent frequency is actual frequency into, in this case, it will be velocity of sound plus velocity of the observer. So, this is the observer, V by 15 divided by velocity of sound minus velocity of the source. So, this is the source V by 10. After solving this one, you'll get nearest value of apparent frequency as 711 Hertz. So, correct answer is option 1. Question number 25. Two motorcycles A and B are moving in opposite direction away from each other with speed 16.5 meter per second and 16.5 meter per second each. Motorcycle A, so it is the source, blows a horn of 420 Hertz. Then the frequency of sound heard by the motorcyclist B is. So, in this case, apparent frequency is actual frequency into V minus VO divided by V plus VS, right? So, it is 420 into 330 minus 16.5 divided by 330 plus 16.5, and correct answer will be 380 Hertz, which is option 1. Question number 26. The change in frequency due to Doppler effect does not depend on. So, it does not depend on the separation between the source and the observer. So, correct answer is option 4. Question number 27. A source is moving with constant speed 10 meter per second on a circular track of radius 200 meter. It emits a sound of frequency 200 Hertz. A listener stands at the center of the circular track. The velocity, the frequency received by the listener is, and velocity of sound is 340 meter per second, right? So, over here, it will not change and that will be 200 Hertz only. So, correct answer is option 2. Question number 28. We have two masses, M1 of 5 kilogram and M2 of 4.8 kilogram, and they are tied to a string are hanging over a light frictionless pulley. What is the acceleration of the masses? So, acceleration will be m1 minus m2 g divided by m1 plus m2. So, it is 5 minus 4.8 into 9.8 divided by 5 plus 4.8 only, which is equals to 0.2 meter per second square. So, correct answer is option 1. Question number 29. A uniform rope of length L resting on a frictionless horizontal surface is pulled at one end by a force F. So, let's say mass of the rope is m. So, acceleration of the rope is F upon m, right? We need to find the tension at a distance L, small l, from the point of application of the force. Okay. So, mass density M is capital M divided by capital L. So remaining length of this backward portion is L minus L, right? So mass of this complete portion over here will be length into mass density. Okay, and let's say tension is T. So this tension is responsible for providing acceleration to this portion only, right? So this is T is equals to mass of this portion into acceleration, which is F upon M. MM cancel. So tension will be F into L minus L divided by capital L. So correct answer is option 1. Okay. Next is question number 30. A player caught a cricket ball of mass 150 gram moving at a rate of 20 meter per second. If the catching process is completed in 0.1 second, the force of blow exerted by the ball on the hand of the player is equals to. The rate of change of momentum is equals to force. So mass into velocity divided by time over here will be the force, and this will be equal to 30 newtons. So correct answer is option 3. Next is question number 31. So we have two blocks, 2 and 1 kilogram, and 3 Newton forces applied on the system. So acceleration will be total force divided by total mass, that is 1 meter per second square. We need to find the normal reaction between 2 and 1. So let's look at 1 kilogram. So this normal reaction over here is responsible for providing acceleration to this 1 kilogram. So normal reaction is equals to mass of 1 kilogram into acceleration, which is 1 Newton only. So correct answer is option 3. Next is question number 32. A projectile is projected with a linear momentum P, making an angle theta with the horizontal. So linear momentum is mass into velocity and the angle of projection is theta, right? The change in momentum of the projectile on return to the ground will be. So when projectile returns to the ground, its angle with the horizontal is again theta, but in the opposite sense, right? So if this is V, then this velocity is V cos theta, and this velocity is also V cos theta, and this is V sin theta, and this is V sin theta. So there is no change in momentum along x-axis because velocity is not changing, but momentum will change along y-axis. Okay, velocity will change along y-axis, and that is V sin theta minus of minus V sin theta. Both are opposite. So let's take one as positive, one as negative. So this is 2V sin theta. So change in momentum delta P will be M delta V, which is equals to M into 2V sin theta, which is 2 times mv sin theta. Okay, mv is P, so it is 2P sin theta, and correct answer is option 3. Next is question number 33. A man of mass 60 kg is riding in a lift. The weight of the man when the lift is accelerating upwards and downwards at 2 meter per second square respectively. So when the lift is accelerating upwards, the weight of the man will be m into g plus a. Right, so this is 60 into 10 plus 2, that is 720 Newton. When the lift is accelerating downwards, the weight of the man is m into g minus a. So it is 60 into 10 minus 2, that is 480 Newtons. So correct answer is option 1. Question number 34. A body of mass 0.25 kg is projected with muzzle velocity 100 meter per second from the tank of mass 100 kg. What's the recoil velocity of the tank? So the magnitude of the momentum of the velocity the magnitude of the momentum of the body should be equal to the magnitude of the momentum of the tank, because initial momentum is equals to final momentum over here, right? So initial momentum of the body is 0, initial momentum of the tank is 0, but finally there's some momentum of the body of mass 0.25 kg. So the momentum of the tank should cancel the momentum of the body. So magnitude wise both should be equal. So momentum of the body is 0.25 into 100, and that is equals to 100 into V over here. I'm just writing the magnitude over here. So V will be 0.25 meter per second. So recoil velocity will be 0.25 meter per second, which is option 4. Question number 35. A bomb at rest explodes into three parts of same mass. The momentum of two parts are minus 2pi cap plus pj and pj cap. The momentum of the third part will have a magnitude. So let's say momentum of the third part is p1 vector. Right, so initial momentum is 0. So final momentum, combined momentum of all these three particles should be 0. That means p1 vector minus 2pi cap plus pj cap should be 0. So p1 vector is 2pi cap minus pj cap, right? So if you find the magnitude, it is under root of 2p whole square plus minus p whole square, which is equals to under root 5p. So correct answer is option 3. Question number 36. In the circuit shown in the figure, the galvanometer G shows no deflection. That means current in this branch is 0. If the batteries A and B have negligible internal resistance, the value of the resistance R is. So if I is 0 in this branch, that means the potential difference across this R should be 2 volts, right? So over here, if out of 12 volts, 2 volt is here, then 10 volt will be here. So current through 500 ohm will be V is equals to I into R. So I is V upon R, that is 10 upon 500, which is equal to 1 by 50 ampere. Right. Now the same current is flowing through this R. So over here, again 2 is equals to 1 by 50 into R. So R will be 100 volt, 100 ohm. So correct answer is option 3. Next is question number 37. The potential difference VA minus VB between the points A and B in the given figure is. So this is the flow of direction of current. So this is positive, negative, positive, negative. Let's start from A. So it is VA minus 2 into 2 minus 3 minus 2 into 1 is equals to VB. So VA minus VB will be 9 volt. So correct answer is option 4. Question number 38. Find the equivalent resistance between the points A and B. So you can see that 2.4, 4 upon 8, 1 by 2, 1 by 2. So this is nothing but the Wheatstone bridge. So this resistance is useless. This 2 and 4 are in series. This 4 and 8 are in series, and then the combination is in parallel. Right. So series of 2 and 4 will be 6 ohm and 4 and 8 will be 12 ohm. Now this is point A, this is point B. Now 6 and 12 are in parallel, so R equivalent will be R1, R2 divided by R1 plus R2, so it is 4 ohm. So correct answer is option 2. Question number 39. Two cells when connected in series are balanced on 8 meter on a potentiometer. Right. If the cells are connected with the polarity of one of the cells reverse the balance on 2 meter. The ratio of EMFs of the two cells is. So E1 plus E2 upon E1 minus E2 is given as 8 by 2, that is 4. So E1 plus E2 is 4E1 minus 4E2, or you can write it as 5E2 is equals to 3E1. So E1 upon E2 is 5 upon 3, which is option 2. Question number 40. A cell can be balanced against 100 centimeter and 110 centimeter of potentiometer wire respectively, and without being short circuited through a resistance of 10 ohm. Its internal resistance R is. So R over here is given as capital R into L1 minus L2 divided by L2, right? So capital R is 10. L1 is 110 minus 100 divided by it is 100. So this will be 100 upon 100, and that is equals to 1 ohm. So internal resistance over here is given as 1 ohm. Question number 41. We have a bar magnet of magnetic dipole moment M, right? So it is M into L, and that is capital L. It is bent at right angle at its midpoint. So this length will be L by 2, L by 2, and the effective length between the poles will be under root of L by 4, L by 2 square plus L by 2 square, right? Using Pythagoras theorem. So L dash will be under root of 2L square by 4, and that is L upon root 2. So new magnetic moment M dash will be M into L dash, that is L upon root 2. So it is ML upon root 2, which is capital M upon root 2. Right. So new magnetic moment will be option 4. Question number 42. The force between two identical bar magnets whose center are R meter apart is 4.8 Newton when their axes are in the same line. If the separation is increased to 2r, the force between them is reduced to. So force is inversely proportional to r power 4. So you can write f dash upon f is equals to r upon r dash power 4. Right. So over here f dash is f, which is 4.8 into r is r divided by r dash is 2r power 4. So this will be f dash is 4.8 into 1 by 2 into 2 into 2 into 2. So this will be 16. So this is 0.3 Newton. Right. So correct answer is option 4. Next is question number 43. The resultant magnetic moment for the following arrangement is. So resultant magnetic moment is given as under root of m1 square plus m2 square plus 2 m1 m2 cos theta, and after applying this one you'll get resultant magnetic moment as 2m. So correct answer is option 2. Next is question number 44. 64 tuning forks are arranged such that each fork produces 4 beats per second with the next one. If the frequency of the last fork is octave of the first, the frequency of 16 fork is. So let's say frequency of the first fork is A, then the next will be A plus 4, then A plus 8 and so on. So you can see that all frequencies are making what? An AP, right? So you can write nth term of the AP by A plus n minus 1 into D, right? So over here, let's say frequency of the 64th fork is 60 F64 and frequency of the first is A, right? So over here it is A plus 64 minus 1 into D. Difference is 4. So this will be A plus 63 into 4, that is 63 into 4 is 252, right? So 252 plus A is the frequency of the 64th fork, okay, and it is in the octave of the first, right? That means it is 2 times the first frequency, right? Octave matlab the ratio will be 2. Okay, so over here A is 252. That means frequency of the first fork is A, which is 252. So frequency of the 16th fork will be 252 plus 16 minus 115 into 4. So it is 312 hertz, which is option 3. Next is question number 45. We have two tuning forks. A and B are vibrating and they produce 6 beats per second. If the prongs of A are loaded with the vex and A and B are vibrated together, then new beat frequency is 3 hertz. Natural frequency of B is 250 hertz. Find the frequency of A before it is loaded with wax. So when you are loading the prong of A and the beat frequency is decreasing, that means FA is greater than FB. So FA minus FB should be 6 hertz. So FA should be FB plus 6, that is equals to 256 hertz. So frequency of A will be option 2. Next is question number 46. At a point beats frequency of n hertz is observed, it means in a second n times maximum sound is heard. So correct answer is option 4. Question number 47. We have two factories and are sounding their sirens at 800 hertz. A man goes from one factory to another at a speed of 2 meter per second. The velocity of sound is 320 meter per second. The number of beats heard by the person in 1 second is. So, apparent frequency for both A and B factory siren will be different because from one factory it is moving away and from it is moving towards factory B. So apparent frequency for a factory A siren is, let's say, F1, and it is 800 into V minus 2 upon V, which is 800 into 318 divided by 320. For factory B, let's say apparent sound frequency heard by the observer is F2, and that is 800 into V plus 2, that is 322 divided by 320. So beta frequency will be F2 minus F1, which is 800 divided by 320 into 322 minus 318, and that is equals to 800 into 4 divided by 320. So it is equal to 10 hertz. So beta frequency will be 10 hertz, which is option 4. Next is question number 48. We have a source of sound S and it is emitting a frequency of 100 hertz sound. Observer O are located at some distance from each other. Okay. The source is moving with a speed of 90.4 meter per second and at an angle of 60 degree. Okay. So in this case, the apparent frequency observed by the observer is. So apparent frequency F dash is 100 into V, which is 330. So let's write it 330 only, divided by 330 minus velocity of the source along the line joining source and observer. So it is 19.4 into cos 60 degree. So it is 100 into 330 divided by 330 minus 19.4 into cos 60 degrees 1 by 2. So after solving this one, you'll get apparent frequency as approximately 103 hertz. So correct answer is option 4. Next is question number 49. A chain consisting of 5 links, each of mass 0.1 kilogram, are lifted vertically with a constant acceleration 2.5 meter per second square. The force of interaction is. So basically this complete 2, 3, 4, 5 link will have acceleration because of the force of interaction between this 1 and 2. So let's say force of interaction is F in the upward direction, right? And mg 0.1 into 4 into g will be in the downward direction. So that is equals to 4 Newton. And acceleration of this complete 0.4 kilogram mass is in upward direction, 2.5 meter per second square. So net force F minus 4 is equals to 2.5 into 0.4. So approximately the value of the force of interaction is over here. It is 5 Newton, because I've taken the value of G as 10. But if you take the value of G as a 9.8, the approximate value of force of interaction between 1 and 2 will be 4.92 Newton, which is option 2. Next is question number 50. We have a rocket of mass 1000 kilogram and it is projected vertically upwards and the gases are exhausted vertically downward with a velocity of 100 meter per second. With respect to rocket, what is the minimum rate of burning of the fuel so as to just lift the rocket upwards against the gravitational attraction? So gravitational attraction mg will be 10,000 Newton, and that is equals to dm by dt into velocity. So dm by dt, that is the rate of consumption of the fuel, will be 10,000 divided by velocity, that is 100, and that is equals to 100 kilogram per second. So correct answer is option 3. So guys, that is it for today's session. I'll see you again with the next paper discussion. Take care everyone. Bye bye.